Welcome. My name's Alex Jenkins. I'm the Director of the WA Data Science Innovation Hub. I'd like to thank everyone for coming along today. I'd like to just open with an acknowledgement of country. So to commence today's proceedings, I would like to acknowledge the traditional owners of the land on which we meet, the WADSIH people of the Noongar Nation, and pay respects to their elders past, present and emerging. So thank you again for coming along, and just for those who don't know, I'll give you a very brief introduction of the WA Data Science Innovation Hub. So our remit is the uptake and awareness of data science in Western Australia. So this is based on the New Industries Fund that the government funded in 2018, and our remit is to ensure that Western Australia has a thriving data science ecosystem. So we work with students and graduates to make them excited about a career in data science. We work with small and medium businesses who might have data science, machine learning type offerings to expose them to the market in Western Australia. And we also work with larger companies as well who might be more mature in this space, and we try and translate their solutions or their learnings, expose their learnings to smaller companies or even different industries. So something like mining and oil and gas, for instance, is very mature in this space, but there are areas like conservation and ecology where the similar kind of mathematics and solutions are relevant, and we can take those solutions and apply them elsewhere. So we're really trying to build an ecosystem around startups as well in Western Australia, and so we encourage you all to talk about us to your data science friends, sign up to our mailing lists, and please keep coming to the events. So just in terms of this topic, this is a topic very close to my heart, data science in mining. My background is in mining and data science. I worked for mining companies for many years, sometimes doing data science before it was called data science. And I started work as a programmer before moving into things like statistics, mathematical mass balancing for processing plants and metallurgical accounting, finding outliers in data in those kind of processing plants, working with APC, so advanced process control solutions, and also on the visualization and BI side. So I suppose I find this a really exciting space, and if I was going to sum up what data science means for mining, I think it's the movement from descriptive analytics and descriptive statistics, where we describe what is happening, to predictive and prescriptive type of analytics. So predictive statistics being what will happen in the future versus what's happened in the past, and then prescriptive analytics, whereas, well, what should we do? If we know what's going to happen, what should we do to optimize our production, minimize our downtime, generally take advantage of the current state of the environment and our operations to maximize our efficiencies and operational values. So, I mean, one area I think this is really exciting is predictive maintenance for vehicles. So I've worked on platforms where we try and move from models where we have regular maintenance schedules for heavy vehicles to a more of a just-in-time model where we're only pulling these vehicles in when we know, based on their conditions or otherwise, that something might be about to happen with the vehicle. And that can save a lot of time, and it leads to increased productivity of the vehicles. It's a great win for mining companies. There's also a lot of space in geological modelling for data science and machine learning to make improvements. And to be fair, I think geostatistics is an area where it could have been called data science 10, 15 years ago. So shout out to all the geologists in the room there who might have been doing data science for a long time. But it's really interesting to see how some of the newer techniques, or even the older techniques but applied with much greater computational power, can really help to extract the most value out of a resource in the ground. Another area I think is really interesting is whole of mine optimization. So that's things where we're optimizing the mill feed to a process plant, right through to just-in-time contract fulfillment and how that impacts our operations. So I've worked at operations where the ore blends were such that penalty elements ruled in certain cases, and the economic value of the ore might change considerably depending on the current commodity prices or how that ore is to be processed. I know that some of the big mining companies are focused as well on how we can change and respond to changes in our environment quickly. So how can we scale up and down production in response to market forces, and how can we do this in a way that's efficient and quick and really reaches our targets quickly. So these are some of the kind of bigger end state goals. But I'm really interested to learn from all of you as well about some of the kind of the smaller starting steps to these sort of end state visions, and learn more about what everyone here is doing in that space. So we've got networking and drinks after the event, so please hang around. I'd like to talk to all of you about what you're doing in this space. I'd also like to just make sure that we don't forget about how difficult machine learning is. So my job is to talk about and get people excited about data science. But I think one of the first rules of machine learning is, well, try not to use machine learning or start without machine learning. And the thing about that is because machine learning is really hard, and there are often a lot of established algorithmic techniques that will work in place of machine learning. And so let's make sure that we take into account that there is a bit of a buzz around this and try and use the more established techniques unless they're not working. So that way we can really pinpoint where machine learning and data science can add value within an organisation and focus our efforts in this space. So to paraphrase a technical expert that I read on Twitter, so when you have a data problem, you can build two solutions, the first being a Bayesian transformer neural network running on the latest cloud-based GPUs, or you can build a SQL query based on massively oversimplifying assumptions. You should put one on your resume and you should put one into production. All right? So when you do those things, let's not forget about, we have to make all of our solutions work in practice. So I think that it's a really exciting time for data science in mining. And I'm more excited every day to learn about the kind of things people are doing in this space. So I'd ask you after the show to please come and have a chat. And WADSIH is always keen to engage with people across all spectrums of business and academia and government to help the uptake of data science. So with that, can I introduce Ben Old from Mining Plus? Ben? Thank you, Ben.
All right, great introduction and excellent summary. So I'm only going to take 1 minute to introduce Mining Plus. Really grateful to sponsor this event. Apparently it's a sellout, better than a concert in a day or so well done to that. But just a quick background on Mining Plus. We're a global mining consultancy company. We're a team of 160 full-time geologists and mining engineers. We're based in 8 countries across 11 offices around the world. So that's all wonderful, but why are we here, right? So our driving vision is passion and excellence in mining. And what does that mean? We love what we do and we're good at it. We love the mining industry and we know it's critically important to every human, has a touch point with every human on Earth. What does that mean in regards to data science? Well, we also love technology, innovation, data science, implementation into the typical work that we do every single day, and we know it's critically important. So we're on a journey, on a learning journey a lot, and I like your comment about be careful about machine learning because it's a cat's cry, it's easy to jump into that. But we've recently started to engage and employ graduate very specific data scientists who know nothing about mining. And it's probably fair to say that many of our technical professionals, especially more experienced ones, don't know a whole lot about data scientists. We're bringing those two together. We're seeing some phenomenal results. And Patrick's here today to talk about some of those. So that's a little bit of background of who we are and why we're here and what we're looking forward to. So I really appreciate the opportunity to sponsor this and be a part of it. Thank you.
Thanks. Okay, can I introduce our first speaker, which is Patrick. So Patrick is a geologist with over 20 years experience in the minerals industry. He spent the first 12 years in remote exploration in the Canadian Arctic and the Northern Territory. He joined Sequent, then Aran's Geo, in 2014 and participated in the early development of Leapfrog Central and Leapfrog Works. Patrick is currently a senior geology consultant at Mining Plus, where he focuses on resource modelling and exploration. Welcome, Patrick.
Hello. So yeah, I'm Patrick Smiley, senior geologist at Mining Plus. And I'm going to talk to you today not so much about data science in a very large sense, but more about small decisions and small artifacts of systems that we're using that are having measurable impacts on the outcomes that we produce. And that, so basically, collect, compute, represent. This is three little catchwords that I stole from a guy called Jer Thorpe. He's a data scientist and an artist. And he designed a part of the World Trade Center Memorial. And I'm not going to tell that story here, but it's worth chasing that up maybe on Medium when you're finished here to actually read his story and how he came up with these three steps. But basically, this is an oversimplified and dangerously reductive description of a data system and how we all interact with it. And small choices that we make and are made for us along this path are having definite outcomes on the products that we're producing. So the first stage in here is collection. In the mining industry, typically this means a drill out in the middle of nowhere, spinning around and bringing up rocks. And for every piece of data that we're collecting, there's also pieces of data that we're deciding not to collect. And we should be asking ourselves not only what data do we collect, but what data we don't collect and why we're not collecting it, what's the motivation behind it. In the mining industry, that motivation is often cost, but sometimes it's also vision or a lack of understanding of where your product is going to be going when you're finished with it. Several years ago, I was working on a gold deposit, and they had deleterious elements that were affecting their processing. They were estimating for these everywhere, but everywhere they went, their gold assay or their gold estimates were pretty accurate, but the deleterious element estimates were off by a fair bit, and they were wondering why this is happening. And when we actually dug into the data, we found that it was because they were only assaying for those deleterious elements inside their ore zones. And so what that means is they weren't getting, unless their deleterious elements and their gold are perfectly coincident, they're not getting a representative sample of these deleterious elements. So when they run all of their estimation on those, they're getting a skewed output. As soon as they started assaying for the deleterious elements outside of the ore zones, then suddenly the accuracy of their models improved, they were getting better results. And stepping outside the geological realm before, I imagine a lot of you have seen this image before. It's kind of a classic illustration of something called survivorship bias. Near as I can tell, I dug into the history of this a little bit, but near as I can tell, this image isn't actually real. It wasn't produced as a part of the original story. It's some much later internet meme edition, but the story behind it is real, and it's kind of interesting. It's all based on the work of this guy, whose name is Abraham Wald. He was a Hungarian mathematician who worked for the US military statistical research group in World War II. They were presented with a problem, and it was, our planes keep getting shot down. How do we stop that from happening? And so what he did was he went and started collecting data on those planes, where they were getting shot, how much they were getting shot, where the bullet holes were, and he calculated the probability of the planes returning with a given number of hits on it. And so here what you can see is the planes seem to be getting hit less on the engine and the fuel system than they are on the fuselage and the rest of the plane. And so to answer the question, where do we reinforce the planes to keep them from getting shot down? What he said was, or this is from a review of the articles that he wrote for the statistical research group, it said, the military was inclined to provide protection for those parts on returning plane that showed the most hits. Wald assumed on good evidence that hits in combat should be uniformly distributed over the planes. It follows that hits on the more vulnerable parts were less likely to be found on returning planes than hits on the less vulnerable parts. So basically, from this, he devised methods on estimating the vulnerability of various parts of the planes. So going back to this image, when you ask the question, where do you put the armor on these planes to keep them from getting shot down, the military's initial idea was to put it in all the places where you see those red dots. Those are the bullet holes. What Wald looked at the data and found was that actually you should be putting more armor on the places where you're not seeing the hits, because the planes that get hit in those places don't come back to give you any data about them. So he was able to see beyond the data that he was collecting and understand that there was a lot of data that he was missing in this system. And I think it would be good for all of us, especially in the mining industry, to understand that we're taking very small bits of known data and characterizing very large unknown bits of ground. And so now after you've collected all of your data, you're inevitably going to run some kind of computation on it. This, you're going to put it in a database, you're going to edit it, you're going to truncate it, scale it, filter it, upward, continue, derive, whatever you're actually doing to it, you're running some kind of computation on it. That can run from the very simple to the very complicated, but sometimes there are choices that are being made by the software package that we're working in or the systems that we're working in that can have noticeable impacts that you don't necessarily think about. So on the screen here are two drill holes. This is actually one drill hole. It's exactly the same color and survey data, and a lot of people think when you take your color and survey data for your drill holes and you throw it into a 3D mining package, a drill hole is a drill hole is a drill hole, it's going to be exactly the same no matter what you do with it. That's not necessarily the case. The drill hole on the left was calculated with minimum spherical arc desurvey method, which basically means the software package takes your two survey points, you have a dip and an azimuth for both of them, it calculates the minimum spherical arc that connects those two survey points. The drill hole on the right, using exactly the same drilling data, was calculated using a balanced tangent algorithm. That's basically a fancy way of connecting your two survey points with straight lines. And so the minimum spherical arc is arguably a much more accurate way of representing what your drill holes really look like. Drills don't go in straight lines. They don't, make a perfect curve when you hit a new survey point and go off in that direction. They're probably curved. But when a lot of these software packages were developed, sometimes 20, 30 years ago, calculating that minimum spherical arc was very difficult. It might have taken a long time. If you're importing 20,000 drill holes into a software package, maybe that takes several hours to calculate that minimum spherical arc, or maybe it's just flat out impossible. And so it persists in a lot of the software packages we use today. And it's not, drill hole desurveying isn't exactly a sexy bit of code to go and rewrite, so it's not a priority for a lot of these software companies. They'd rather work on, maybe some machine learning or resource estimation or implicit modeling functionality rather than go back and revisit something as simple as drill hole desurveying. And so on screen here, you have about 300 meters of drilling, and they're pretty close up at the top, not deviating too much, but then you get down about 100 meters, and there's a couple surveys just within about 30 meters, suddenly using exactly the same data, but calculating it in two slightly different ways. You have the drill deviating by about 7.5 meters and staying about 7.5 meters off that other trace for the rest of the hole. And this has very real impacts when you start to build wireframes based on this data. If you're taking those wireframes from one software package and putting them into another software package that uses a different drilling desurveying method, then suddenly your wireframes might be off by 10 meters. Suddenly you don't have all of the high-grade samples inside those wireframes that you thought you should, and you're going to have very material impacts on the outputs that you're producing. Now sometimes it isn't even enough to put all of your data into two software packages that use the same, or what we thought was the same desurveying method. So on the left here is a wireframe that we built in one software package using a balanced tangent desurveying method. We then transferred it into a second software package to run some resource estimation on it that also used a balanced tangent desurveying method. And in the original software package, sort of in the middle where those red and green lines are, there's a very high-grade assay. In the original software package we built it in, the wireframe snapped perfectly to that high-grade assay. When we brought it into the new software package, even though we thought we were calculating everything in exactly the same way, suddenly that drill hole had moved by about 2 or 3 meters. We have to rebuild that wireframe to include that high-grade assay all of a sudden. So basically that's what we had to do, is shift it a little bit over to the right. And what we found is that even though we thought we were using the same calculation method, these two software packages basically had a very slightly different balanced tangent algorithm. And the drill hole in question here went about 150 meters without having a survey in it, which is an exceedingly long way to go if you're not familiar with this kind of thing. And so it's a problematic drill hole. It's a fringe case, but still a very small decision that's being made by the software package you're running with is having a very material impact on the system that you're building. And again, even when you have exactly the same drilling data, exactly the same desurvey methods, sometimes when you move wireframes that you're building from one software package to another, there are very small shifts in those wireframes. So this is a very zoomed in view of the outside of an ore wireframe that we built, and in purple running across the middle of it is a drill hole, and it's running almost perfectly parallel to and almost right on top of one of the triangulations of these wireframes. So when you export a wireframe from one software package into another software package's format, there's going to be very slight changes in that wireframe. Usually it's precision, and it's basically the way that the new software package calculates it will be slightly different to a slightly different level of precision. That caused this wireframe to shift by less than ½ a centimeter in the new software package, but that was enough to include 10 samples out of about 900 that were in the wireframe. It basically took 10 samples that weren't in the original package and included them in the new package you were running the estimation in. So we ended up with about 1% more samples inside the wireframe than we anticipated when we built it. And that's effectively because on the right here, you can see the original wireframe in green. This is a sliced and zoomed in view of that previous image. So on the right is the original wireframe in green. On the left is the exported wireframe in red. And right sitting in between those two with a difference of less than ½ a centimeter is one of the samples that got pulled into the wireframe just by shifting it to a different software package. So when we're running these algorithms, when we're running all this computation on the data that we've collected, it is having very real impacts on the systems that we're creating. Sometimes things that we don't think about, often things we don't know about. When you start getting to the representation phase, we really need to do a better job of communicating, I think, the risk of the models that we're building, and that we are characterizing very large amounts of unknown ground from very small amounts of known data. I think everyone in this room, all the geologists in this room, know that you have tiny, tiny, tiny amounts of drilling, and you're building these very large mineralization models or wireframes or block models. And when you deliver them to your client, they're all filled in, they all have numbers assigned to them, and it looks like this model is the version of the truth. But in reality, we are characterizing enormous amounts of unknown from very small amounts of known. So several years ago, I had a lawyer friend in Canada contact me, and she was working on a lawsuit. And it was all to do with tunneling. So a tunneling contractor had gone massively over time and over budget building this tunnel, and there were lawsuits about whose fault is it, who has to pay for it. And opposing counsel had written a very long brief about how the tunneling contractor had only collected 12 centimeters per linear meter of drilling data along the path of this tunnel. And how irresponsible is that they only have 12% coverage along the entire path of the tunnel. And so she rang me up and she goes, "It sounds like we're screwed. Are we screwed? Is there any way that I can say 12 centimeters is actually a lot? And you need some clarification on there. Is there any other drilling? Did they build a model? All kinds of other questions." But when I got that answered, it turned out that this company had actually collected a lot of data. It just wasn't all directly on the path of that tunnel. And my friend, who's a very smart lawyer, she's argued cases in front of the Supreme Court of Canada. She's even worked as counsel for mining companies before. She had no real idea that the models that we're building were basically all about taking those very small bits of known data and broadly categorizing things that might be hundreds or even thousands of meters away from that based on those very small bits of known data. And it turns out in this particular case that 12 centimeters per linear meter of tunnel was an enormous amount of data. And in order to gather that much, I figured they must have been pretty worried about what this tunnel was going to look like during construction. And so that got me thinking about exactly how much characterization of unknown are we doing. So I went and ran some numbers on an ore deposit I worked on several years back. So they had collected about 30,000 samples. Of those, about 10,000 were ore samples. You give those about an average weight of 2.5 kilograms a sample. You have 25 tons of ore that got shipped off to the lab and assayed. From that, there was about 1.5 million tons of ore in the resource estimate. And so a little bit of simple math there means that 99.9983% of that ore was completely unknown, and we're characterizing it from 0.0017%. And this is not a risky deposit. There was nothing outlandish about this. It went on to mine for several years and produce a fair bit of gold. Everyone was pretty happy with it. But I think we don't do a very good job of communicating beyond the technical sphere that what we're actually doing is estimating essentially parts per million and characterizing and making billion-dollar decisions sometimes off of fractions of a percent of known data. And so when it comes back to this collect, compute, represent, I think we need to be very clear about the decisions that we're making about why we're collecting data and why we're omitting data. Once we're computing that data, understand a little bit better the decisions that are being made for us by the systems that we've created. And once it comes time to represent and pass this client on to the next stakeholders, we need to be a little bit clearer about if we understand these systems, then basically the criticism that we provide of these systems we've created will be much more meaningful and will be communicated clearer to stakeholders further down the chain. And that's all.
Thank you very much, Patrick. I'd like to introduce our next speaker, Andrew Bigg. Welcome, Andrew. Thanks.
Thanks very much, and thanks for the opportunity to speak here today. Just as we kick off, I'm not quite sure of who's in the crowd, so I just want to do a bit of a crowd survey. Who's here actually from a mining company here? Hands up? Great. Who's from a service supplier in the industry? Are there any actual data scientists in the room? Okay, very good. I'm not a data scientist, but I bought our SME on data science, so hold the technical questions to the end of the presentation, please, or at the end of the session, and we can address those later. Just to give you an example of how small the mining industry is, Ben, don't want to put you on the spot, but the last time we spoke, you probably don't remember me, I think you were finishing your supervising time at Burncut, maybe at Mount Magnet, many years ago. Green overalls, we were both covered in dust, and I was just turning up for my first swing, so that's how small the mining company is in the early 2000s. South 32, so those of you who may or may not know South 32, we're a globally diversified miner. We have 11 operations across Australia, Africa, South America, and 2 prospective development projects in North America. We demerged from BHP Billiton in 2016, and effectively 2 companies were formed. Commodities we mine bauxite, we create alumina, create aluminium, we mine manganese, we mine silver, lead and zinc, metallurgical coal, and nickel. What I just wanted to talk to you today was effectively about how we think about business intelligence and analytics within the business. So I'm just going to start through the context that we get from the organisation, which really sets our agenda. Give you an overview of the program that we have to deploy business intelligence and analytics across the business. And then I've got some practical examples of how we actually do that and some things that are real-time operational in the field. For us, it all starts with a strategic risk. And we have 12 strategic risks that are governed by the board. And one of those strategic risks is around maintaining competitiveness through innovation and technology. You know, the threat is you fall behind, but the opportunity is you actually create competitive advantage. And we look to manage both of those aspects of the risk. That sets up our data strategy goals. And really there's three key pillars of that. Our data is trusted and reliable, which is actually quite a hard thing to do. It's readily and freshly available, so we can access it for the people who need to access it at the right frequency. And the third element, which is something that I think definitely the industry experience I've had, we lost sight of, particularly when technology became almost a bit of a buzzword in the business, but that our data assets achieve their targeted return on investment. And we wouldn't be the only company that spent a lot of money chasing this in the past. And we're rebuilding this function now, which is why I've joined the team. That sets down to how we're structured as an organisation, and really we have a digital technology function which looks after our data platforms, data strategy, and data operating model, which is basically who's accountable for what. And then we have an innovation and business optimisation group, which is where our business intelligence and analytics teams are hosted. And really that's all about taking the data that the platforms team provide, creating insight, driving action, and then delivering a result. We deploy that across the business through effectively data and business intelligence analytics standards and processes. And we do that because we have found that in order to drive best practice, you need some standards for the teams to operate in order to enable vendors to operate in a predicted and repeatable way and get the quality we want. We really need to highlight what we see as good practice within our business, and then it's much easier to engage from us rather than starting from a blank slate. The program overview for us, so we really have 4 broad work streams that we're driving towards in the business intelligence and analytics space. I might start, when we talk about business intelligence and analytics, that includes data science, visualization, DevOps, and our GIS platform. We've spent the last couple of years in that first work stream there developing an operating system for South32. It's a principle-based operating system. It covers aspects from leadership to understanding your value drivers within the business, understanding how to manage variance in performance, and then having continuous improvement cycles. So one of the big challenges that we've got and that we're driving towards is effectively enabling that within the business, and we believe there's quite a big prize for us to actually go out and get that. So what we really need to do was set up business intelligence standards so that we get the right quality happening at all the times. Looking at digitising the operating system, and in our language, that it's performance-centred deployment. That's around having clear data available to whoever it is based on their time horizon, the insights that they need to take action. So if it's an operator, it's in-shift data, it's around variance on process. If it's a supervisor, it's how the shift is performing. You know, superintendent daily, weekly, manager monthly, and rolling up the organisation, all the way cascading up to how the overall business is running. And then the third one there is around effectively an improvement pipeline in the corporate centre. Now, we do look and do a lot of projects in the operational optimisation space, but we do believe there's a lot of competitive advantage in some of the corporate activities, which is really things like how we reshape the portfolio, how we take a view on market prices, how we take a view on and see value where our competitors don't. The second aspect there is, and this is some learnings that we've had in the industry, we did jump in quite deeply like a lot of businesses. And when we looked at it, we invested really heavily in quite detailed and I'd say comprehensive programs, but we didn't do a great job in investing in capabilities to sustain that and to see long-term value through that. So one of the programs that we're deploying is the establishment of operation analytics hubs. We're piloting into one of our operations at the moment, and this is around having a team that can deal with 80 to 90% of the business intelligence analytics opportunities within the operation. And then they engage the corporate team if there's a higher level of capability required, or if there's something that would then spread across the next 11 operations. We're really sort of investing, not heavily, but we're investing a lot of time in that because there's a lot of opportunities from minimising variance in our operations. Our operations are really keen for it. I wish I had that when I was running our operation before I moved to Perth. But in there, we're looking at simulation pipelines, analytics pipelines, and visualisation pipelines. Those things range from things like predictive models around financially optimised maintenance strategies, looking at digital twins for where our constraints are in our production processes, and so forth. So there's some pretty good work going on from that perspective. From the third program there, GIS integration, we see a huge opportunity in utilising our GIS platform more than we have. It has a great, we use the Esri platform with ArcGIS. It's a great integration tool. When we look across our various systems across the business, and if you take an operating mine as an example, there's a lot of pieces of equipment or processes that have a location attached to it that you need to understand how they are, how they're performing, and what their interactions are at pretty much at all times. So when you think of fleet management systems, noise monitoring, dust monitoring, live feedback from components on trucks, fatigue management, collision avoidance, all these systems that are operating in the business, we see GIS as a great platform to try and integrate some of these things, which will give us an opportunity to not only just remove duplicate systems, but have a much clearer interface for people to interact with. So the key pieces of information we're trying to manage on a daily and shiftly basis and a minute-by-minute basis is available to the people who need to take action against that. And then the fourth one is around really enablers and capability development. So for us, this is about, we did some numbers, we've got about 1,000 to 1,200 engineers / business analysts within the group who are dealing with data on a daily basis, who are doing forms of analytics. So this is really about giving them the best possible tool set. One, give them the tools to do the job, and two, run capability programs so we can uplift their skills so that they're getting the best out of the time when they're going and touching data. That goes all the way from data citizenship processes around making sure that it's trusted and reliable, back to the data strategy that we had, and all the way through to how to create powerful visualizations or get your the insights out of the data into actual action being taken. One thing that we've learned, we've got reams and reams and reams of data flying around, a lot of analysis, not a lot of action that was coming out of it. So we've really been disciplined around prioritising the data sets. We have quite rigorous investment thresholds. So when we're talking return on investment, we're either talking about a very clear financial threshold that needs to be met before we progress further. So we're happy to fail fast, but we need to have a clear line of path for return on investment, improve safety outcomes, or reduce residual risk. At the end of the day, they're the broad filters that we push that through. So that's a bit of an overview of the program. In terms of the practical examples, here's 4 that I've picked out to share today. We completely agree. Start with the basic look at the data first. We have found that a lot of the basic improvement opportunities is just people looking at the data better than they have in the past or having better access to it. But there's a little bit of a diverse range here. We actually use machine learning to look at things like our diversity and inclusion statistics, not just from a statistics perspective, but how to change the way that we operate to be able to meet the targets that we're after, how to identify people or types of people at risk so we can put preventative strategies in place. That was a bit of a social experiment, which was quite interesting. Never thought we'd be doing that type of work, but we did, and was well received within the business. This is a really practical tool, probably a little bit less from a data science perspective, but from integration with the GIS, we've got quite a detailed safety and risk data set that gets updated on when events happen or when observations happen and things like that. We integrate it with our GIS system to create what we're calling a hotspots and blind spots tool. So graphically, the operation can see on a daily, shiftly, monthly, quarterly, whatever time period they want to, where our events are clustering from a location perspective or cutting it by a risk perspective. So that's the hotspots component. But the blind spots is where we're not doing inspections on those types of things, either from a location or a time period or a risk event. And what that does is it arms the leadership in the operation to say, hang on, we should have got there yesterday, we didn't, we can see that we actually didn't get there, let's get out there and make sure we have a look today. Or, hang on, this area might be area, I'm just going to pick a name, Area 5. Area 5 is where everything's happening, but it's happening on Saturday night shift. Let's make sure we get some good leadership presence or understand what's going out there. So it's just visualising the data in a better way and allowing people to intervene on a different basis, make better decisions. C, this was an automated piece of work that was done. Those familiar, all the miners in the room, anytime you want to let some sort of explosion off, you've actually got to make sure people are safe first, equipment's safe. So we were able to automate exclusion zones, and this came off the GIS platform as well, and use the smarts in the GIS platform to recognise roads and access points as well. So all the blast guard sentry points and the exclusion zones, critical equipment that was has been identified as well, all comes up automatically. I don't know if anyone's had experience here, but this can go wrong pretty quickly. Pumps can get blown up, equipment can get blown up, people can drive into a blast shot where there's a road that hasn't been blocked off. So a simple tool, but very effective and saves a lot of time in the operational space. And the last one here, Alex, you mentioned APC in the past in the introduction, but we have got a lot of capability and have done work in the APC space to improve the performance of our operations. That's all about throughput increases, yield increases or recovery depending on where the constraint is in the plant. So we do a lot of operational optimisation, but here's some of the examples I thought I'd share. There we go. That's it.
Yeah, thank you, Andrew. Okay, our last speaker today is Richard Lee. So Richard is a technology strategist with over a decade of experience across the mining, education, finance and construction industries. Richard has worked as an AI and IoT engineer, solution and enterprise architect, project manager, business analyst, DevOps consultant, capability manager and practice lead. A technologist at heart, he has deep experience in hybrid architectures and technologies and is driven to ensure organisations can capitalise on opportunities in a forever changing technology landscape. So welcome, Richard. Thank you.
Coming today, actually, Justin Rowling, who was a colleague of mine, was actually meant to talk today, so he couldn't make it today. So I've actually come in last minute to help out. And his role is actually a technology strategist, and I've come in as what we call at Microsoft a global data and AI specialist. And what that typically means is in my role, I look after both mining and utilities customers. So my mining customers are global, hence the global there, and really my role there is to ensure that they get the most value out of our data, AI and IoT products, the Microsoft Azure ecosystem. So a lot of my background has been the development and delivery of these products, and now I do a lot of talking about it and doing architectures and stuff like that. So today, what I wanted to do is in terms of contents here, and obviously I was scratching my head about 2 hours ago trying to figure out what to bring to the table here. I wanted to break into two different parts there, and one was really just to give some justice to what Justin was going to talk about. He wanted to talk about some of the themes that we're currently seeing in the mining industry from an analytics, AI and IoT background. And then what I'll do also, just to sort of bring it together at the end, talk about a particular use case, as I was actually involved with Newcrest Mining before joining Microsoft, which does encompass both IoT, edge architecture, and also AI as well, to deliver actual value back to the customer. It's actually a very interesting project, a lot of learnings that came out of it. So with that said, first of all, with the data and AI side, I break into both data and AI and optimization. And what we're seeing across the board is increased adoption of AI and IoT to eliminate a lot of the manual work and often lagging processes. And that's happening across the board, just both here in Australia, but a lot of this we're seeing a lot as, over in abroad as well, especially in areas of South America. Lagging processes, typically we don't see too much of that when we're talking about operational space over here in Australia. A lot of the IoT and data acquisition technologies and devices are in play already. So to acquire the data typically is quite a lot easier here locally compared to abroad. And that comes from a maturity thing as well. So what we're seeing abroad more so is around to try and eliminate a lot of these lagging processes. And for those who are in mining, you've probably heard about fleet management systems. They're quite leveraged quite a lot over here locally, not so much abroad. And with those manual or mobile equipment that aren't connected to FMS systems, they've got to think about ways to try and eliminate the manual ways of actually acquiring that data and pulling it out, whether it be through manual plod sheets where people are writing them down, or actually physically maintainers going to the equipment and getting the safety information directly off the mobile equipment, whether it be Komatsu or CAT or whatever it may be. So what we're seeing is increased adoption of these technologies to eliminate all that manual work and lagging processes. On the manual side, just to touch on like the manual plod sheets, what we're also seeing is technologies around to actually ingest a lot of unstructured data. So we're talking about is PDF documents that may be scanned, the digitization of these and bring it into your analytics environment. So we're seeing more and more of that happening. But to sort of jump on the back of that, those comments around getting access to vehicle data, we're actually seeing the access to it improving quite considerably. For those in the mining industry, you may have heard of a product called Dash, and that's a product that's been built around health and safety concerns around maintainers and getting access to mobile equipment. The great thing about this product is that they've actually been partnering with OEM providers actually to get access to the equipment to get the data out of it. Obviously, these are for safety reasons, that's why they've built the product, but what that actually means is they can actually liberate a lot of the other data off the equipment directly into the data estate. So what we're seeing a lot of these vendors out there using our technologies, IoT technologies and cloud technologies to really streamline the data into the platform and to do predictive maintenance, predictive downtime, optimization techniques over the top of that data there. Also, what I'm seeing more on the data analytics side is around this discussion around, do you want a centralized platform or do you want this highly federated platform? And this is quite common, especially around globals in mining, where do you have your centralized data warehouse or database or platform here locally in Australia, or do you want to push it back to the assets? And there's pros and cons to each direction. Having centralized, you can really have a close eye on the operational cost of your platform, especially around if you're a cloud platform there. But for you, the cons around that is potentially around multiple partners or parties or assets trying to operate on the same warehouse or platform, and a lot of friction there trying to get access to that data. On the flip side of that, if you go to a federated model, lots of people are talking around, well, that means agility. So you've got control of your own data, you can get access to your own data when you want it. The assets can actually then start building analytics over the top of it. So there's a lot of discussion in that. Around taking AI to production, it's still hard, and this isn't just for mining, but across the board. And we call it jumping the chasm here. It's very easy to create data science and IoT or data science type experiments locally. You have your laptop, you might have Python, you might want to do Bayesian model or whatever it may be. Once you've got your model there, great, you've grabbed the data, it's been manual and you've got the prediction, but how do you actually operationalize it? And that's very hard. And technology is one part of the question, and that's really catching up. And that's what we're doing here at Microsoft a lot around MLOps, if you've heard of that. But also there's the process side of it as well, the organisational side of it as well around MLOps. So we've got to start thinking about when the model's in production, how do you actually monitor it? How do you know if it's accurate still? How do you know if the infrastructure is still reliable and still up? How do you know when you've created a new model to replace the other model that's in production? How do you automate that whole process? So we've got a lot of process here at Microsoft to help customers do that. And we're seeing a lot of partners as well building their own solutions, partners of ours build their own solutions on the Microsoft ecosystem to help customers with that journey as well. And the last one is I put in there because this came to mind because a couple of customers are actually asking around this at the moment around AI-driven digitization of legacy mine documents for compliance reasons. And it's kind of an interesting one where lots of legacy assets have got lots of old documents that are actually stored away basically in a room, and it's very hard to access that, especially in this digital world, and access it quickly. So what we're seeing a lot of customers now do, or at least think about around how do we scan and digitize that into PDF format, but then how do we bring that into the Azure ecosystem and actually index it and make that data readily available to you to do your analytics or just searching of that data. The compliance comes around where a small use case came around where people, whether it be a legacy mine or not, can come back to the miner with a claim saying they've been injured or health-related reasons. And to the miners, it's actually very hard if they haven't got access to that document. It's actually really, really expensive to try and do any sort of counter against that to prove that potentially they are right or not right. So typically what they've done is they've just paid it out. But through the digitalization of these documents, they've got the data there readily available. They can index, they can search it all very, very quickly to understand where their position is when it comes to the claims that come through the door. And the product we use around that is around cognitive search, for that in the Microsoft area. The other theme is around optimization, and what we've been thinking and seeing across the board for a while now, I'm sure everyone's very much aware of this, around optimization as a mindset has been in motion for a while now, and it kind of came to mind around obviously the spiking of the iron ore price that recently went up, it's come back down, but a lot of our iron ore customers have been thinking about this, especially from a cost perspective, 6 months ago, 12 months ago, and they were looking to optimise their data estate and being mindful that the iron ore price was going to come down at some point soon. And what we're also finding is when the optimisation maturity journey, depending, and it is even within the same miner itself, depending on their geography, they're at differing maturity levels. So an example here in Australia, we're very, very fortunate with the miners that are here. They've got great connectivity to the data. Their acquisition part is sorted. They've got the data in a lake, or could be in the cloud, or could be on-premise still through historians like AussieSoft Pi, but the data is there readily available for them to start doing AI or analytics over the top of it. But what we're finding abroad, especially in the Americas, it's not always the case, and it's actually quite hard to actually get to that data and get it off the machine. So you can't even start thinking about AI because you've got to get to the data first, but then you've got to start thinking about the quality of the data as well before you can start thinking about the analytics, the AI, etc. over the top of that. So that's when we start thinking about the IoT side of things and the devices, and how can we make it easy for them in a plug-and-play manner to actually connect to these OEM equipment manufacturers' devices and equipment, liberate that data and bring it into the ecosystem that they have there, typically Azure for us. Also, we're seeing autonomous fleets are still a focus, but concerns on interoperability, but also an extension to that around building modular IP that can be used between fleets or even between companies. What we're seeing a lot of miners at the moment building their own bespoke approaches to building autonomous systems at the moment. And it leads me to my last one here around optimization through simulation and digital twins, which is sort of off the back of the autonomous fleets as well. What we're seeing a lot, of course, digital twins. I'm sure if I ask 10 people here the same question, what do you think a digital twin is? Probably get 10 different answers, and it just varies depending on your background, how you've been using digital twins in the past. What we see as digital twins is obviously the digital representation of physical equipment, but really an extension of that. How do you simulate over that data, over that digital twin to optimize for that prescriptive approach to actually help you with decision support, or ultimately close the loop and actually control that equipment as well, whether it be mobile equipment or fixed plant equipment as well. And I guess just to sort of finish that off, we've got obviously a lot of products within the Microsoft stack that obviously I care about within my remit, that we help a lot of customers in these areas. One particularly interesting one is around a product that we got in our R&D area of Microsoft called Project Bonsai. For those data scientists here before, really Project Bonsai is just a product that we acquired about 2.5 years ago that is democratizing the use of deep reinforcement learning. So it's not just to predict on what a value is going to be, but it's actually going to tell you what your next step should be to get to that optimal state. And if you take that to the next step, you can actually use this technology to actually control equipment as well. For example, which I'll turn to in a second, around a gyratory crusher, for example. How do you optimize that? How should you be setting the gap of your crusher? But before jumping ahead, what I wanted to do is just finish off on the discussion today around a use case for Newcrest mining, one that I was involved with and know quite well. Newcrest Mining is a global gold miner. For this particular use case, we did it at one of their mine sites, Cadia, which is in central New South Wales, just a little bit outside a town called Orange. And if you like your wine, Orange is a very good region for your wine. But here, they actually do block cave mining. And for those that don't know, block cave mining is essentially where it's a low-cost way to mine once you've actually got the operation set up. And essentially they get the ore body there, they understand where it is, and they spend the first part of the mining to actually develop and build the tunnels underneath the ore body, and they build the infrastructure underneath that ore body, whether it be crushers, conveyors, and all the mobile equipment. And what they actually then do is use explosives to blow the ore body up above and use gravity to actually bring the ore body down, and they use it then to get the ore onto the mobile equipment. They'll crush it underground and convey it back up. So essentially, this is the process that the Cadia mine site do to actually to mine the ore at site. Now, for this particular site, they've got it's 1.3 kilometres underground. They've also got 3 gyratory crushers that operate underneath the ground as well. And if you can imagine, I'm not sure if you've been underground before, 1.3 k's, obviously quite deep there. But when you go to where you see these gyratory crushers are, it's probably about taller than the roof here, where these gyratory crushers are. It's very, very tall, and they've got 3 of these underground. And what happens is essentially, as you can see up the top there, the ore will fall through gravity to the ground, will get picked up by a loader, and they'll get loaded into what they call the ROM bucket up the top there. And that's the first part, or the first bucket of the process to actually start grinding the ore that comes down. Now, as you can see, it goes in the ROM bucket, it gets conveyed into the feeder, it goes into the mantle, which then crushes the ore in the middle there, and goes into what we call the crushed ore bin, which then later gets fed into the conveyors that then go up to the top of the surface. Now, this particular use case is around the crushed ore bin. And for the operator that controls the feeder of putting the material into the actual mantle piece, they actually have to understand what ore is coming downstream, but also understand the level of the crushed ore bin at that time. Now, obviously, if the crushed ore bin is too high and they keep the feeder on and they keep crushing it, it will overflow, and that will cause a massive downtime event. But also on the flip side as well, if they actually keep it too low, they can actually start damaging the equipment as well. So they've got to keep it within that limit as the operator continues to bring the crushed ore into the crushed ore bin. Now, the issue was with the one sensor that actually told them what the level of the crushed ore bin was would actually fluctuate on and off and stop working from time to time, randomly. And they tried many different sensors with the same sort of issue of cut in and out. And what would happen is when it did cut out and stop reporting the correct level of the crushed ore bin, they actually had to stop that whole circuit. So basically, instead of having either 2 or 3 gyratory crushers, running that up, they go down to 1. As you know, mining, less throughput, less money coming through, less revenue. So obviously a big issue there. Now, from memory, I think it was around at least about over 20 hours worth of downtime a month, which is quite significant, especially with the throughput there. Now, tried many different approaches, but what we decided to do was try an AI-based IoT approach, where essentially we used the Microsoft stack there to build an AI model to when the sensor was predicting the wrong level of the crushed ore bin, for the AI model to kick in and actually predict what the actual level of the crushed ore bin was. And to get to that prediction, it would use the different inputs upstream to then make the prediction of what the crushed ore bin was. And also use a lagging over the past, I think from memory, past 12 hours on the different values as well. So I also use lagging indicators and the current inputs to create the prediction of the level of the crushed ore bin. So this particular project took over a year, which is interesting because when we first mapped it up in a project plan, we had 3 months. So it went overran by quite a bit. But the value that was given back to the company was enormous. And I think it was in the tens of millions in the first month that they got back from eliminating the downtime through this AI model. So with this particular use case, we used the entire Microsoft stack, also with a partner called MATLAB as well that created the model and hosted it within the IoT Edge environment. And what we were then doing on the next steps around that was then creating the MLOps pipeline to actually automate that whole process around when the data was drifting, when to trigger a retrain on that model and start that whole process to kick it back in. So this has been going well. It's been in operation for a while now. Now, what I would see the next step after this, and just to quickly loop back to one of the other the points I had in the previous slide around deep reinforcement learning, is how can we optimize this process even more? So we're looking around how can we increase the throughput without taking away the potential fragmentation size of the ore going through the process as well. As we know, we want to increase the throughput, but not always do we want to do it at the expense of the size of the frag that comes through for energy reasons downstream. So we're going to be looking at approaches using the bonsai technology and deep reinforcement learning to potentially help them in this optimization process. But with that said, that's all I had to talk about today. Hopefully that was all right, but more than happy for questions and answers later on. So thank you.
Thanks very much, Richard. Okay, can we get all of the speakers up to the front and we'll just get some questions for the audience. Did you guys want to just test that mic as well? Does it work? Okay. Have we got any questions from the audience? I had one. So we've got a mining service provider, a mining company, and a technology service provider. If I'm a young data scientist, what's the best way to get the attention of your respective companies? I'd like to hear from all of you on that one.
No, we're pretty open. We want to be a bit more active in the data science community.
Yep.
Which is one of the reasons why we're here today, and we want to pay it forward. So we're quite open to any proposals, really.
Okay.
And we're not fixed on team size, but if we've got, like I said, clear return on investment, we'll invest to grow. And
people shouldn't let a lack of mining experience hinder them in this space?
Yeah, one thing I didn't talk about, which is what Ben talked about in his intro, was none of these projects get done in isolation between data scientists and engineers. And where we tried data science on its own, we get a suboptimal result. Sometimes when we try SMEs on their own, they get to step 6 when they can get to step 12. So we found the best results for us is to partner with SMEs and data science professionals, and that's where we've got our breakthrough outstanding results. So
great.
That's what we follow.
Thanks, Andrew.
I think we're broadly, similar. Typically, we operate in a space that kind of runs from resource modeling, resource estimation through mine planning. So we're probably mostly looking at solutions that's in that space, but we definitely don't have a lack of experience with the mining industry. So the data scientist we currently have has almost no knowledge of the mining industry, and so it's been a process for us learning about what he actually is doing with the data that we're gathering, for him to actually learn how we apply the data and what we need to do with it. So basically, we're looking at optimizing and automating processes that we currently do that are very manual and user focused.
Yep, great.
Yeah, it's an interesting question. Microsoft is a very big company, lots of different business units within it, and broadly you've got the consulting side of the business and you've got the marketing operations side of the business. I'm on the marketing operations side of the business, and definitely what I'm seeing within our business unit, go back 1 year ago, we had a broad technical unit, what we call the cloud solution architects, and they were quite broad. You had some people that were AI in there, some people that were data engineering, visualization, etc. But over the last 6 months, they've actually crafted out, carved out a section of that, or for what we call AI ranges, essentially just building out the data scientists that are going to come in and actually augment customers and bring their own AI skills and help them along the maturity of the journey. So I think really people that want to join, it's just really around connecting with as many people as you can, within a company, and showing your curiosity and interest in the field. Because definitely for us, it's all around the curiosity of wanting to learn more, extending yourself, and wanting to, I guess, serve best with your customers. On the consulting side of the business, data scientists have been there for a long while as well. So they're all over LinkedIn as well. So they quite often come up as opportunities for job applications to go for. So it's just really putting it out for those when we come through.
Great, thank you. So on that, I would say if anyone, I'd encourage you during the networking to speak with these guys and other people from the mining community. And if anyone gets a job or starts a project or something, please let WADSIH know. So the government fund us, fund WADSIH, and they also like to know, what we're doing back with the community. So if you get a job or you start a project, please let us know. If you have a good night's sleep, send us an email. We really want to know how we're having an impact. I might ask if there's any further questions that we just take it to the networking side of things. I'd like to thank all of our speakers for coming along today, and also a big thanks to our marketing and communications coordinator, Alicia Fairbank, for organising this event. So can we give everyone a round of applause? So please hang around, enjoy some drinks and something to eat, and look forward to talking to you all. Thanks.